Welcome to Research Methods. In this lecture, we'll be talking about issues relevant to the measurement of variables. So a couple of important questions to think about first. First off, what is it exactly we're measuring? Well, in the behavioral sciences, we talk about measuring constructs, right? And this is where it differs a little bit from other hard sciences, where the constructs you measure are maybe more objective, where you say, okay, I'm going to measure how heavy something is, its mass. You know, you get several different scales, and they're all gonna, if they're well calibrated, they should all pretty well agree. Yep, that's how much mass that thing has. Now we're measuring constructs in behavioral science. We're saying, okay, I want to measure how angry that person is. Now, if I get different people to come up with different ways to measure how angry someone is, they may come up with different measurements, right? There may not be all that good of agreement about how angry someone is, because the constructs that we're looking at and that we're trying to measure are a little more difficult to define sometimes. And that's why we have to talk so much about paying attention to how we're choosing to measure something, because those choices have an impact on the conclusions we can draw. So that goes to the next question: why do we care so much about measurement? Well, because how you measure something will influence the level of construct validity you have. Right? When construct validity is the degree to which you're measuring what you say you're measuring. Right? So if I say I'm measuring how aggressive someone is, then I'm really measuring that. I'm not measuring maybe how angry they are, or how different than me they are. I really am measuring this construct of aggression. And it's really important to measure what you say you're measuring, for perhaps obvious reasons, but in terms of what we'll talk about here, because of the impact on internal validity of a study. So especially if you're looking at the cause and effect relationship between two variables, you're saying, okay, yeah, I think this treatment is going to reduce someone's depression. Okay, well, you go through and you do the study, and the numbers are different from pre to post, and you say, yeah, look, the numbers are different, they're less depressed. Okay, well, maybe they're less depressed. Did you actually measure how depressed they are? Because if you didn't, if you have poor construct validity, then the truth of your statement that, yeah, this treatment affects depression has no basis, right? So construct validity really is a requirement, a prerequisite for internal validity. The same thing for external validity. If you want to generalize some finding about a relationship between variables beyond your study, well, then it needs to be true in your study of what you measured, right? So yeah, I really did measure depression. Before I can say that whatever the effect on depression I found, or the relationship between depression and something else, if I want to be able to generalize that relationship, that truth about that relationship beyond the people in my study and how I did things in my study, then I have to be very confident that I measured what I said I was measuring. I have to have good construct validity. So a couple of different things that we'll talk about that influence our conclusions in terms of measuring variables. An overview here. We'll talk about the reliability of how you're choosing to measure something. We'll talk in greater depth about construct validity and different types of validity that contribute to construct validity. We'll talk about sensitivity, specificity, and variability. And then we'll also talk about the different scales of measure. Starting with reliability. So for classic test theory, excuse me, the reliability of an instrument is equal to this kind of proportion, right? Where you imagine that when you're asking somebody a question, there's some score for their answer to that question that is the true score, right? The absolute right answer for them in terms of estimating some level of a construct. So if it's some question about how depressed are you, there's some number that perfectly represents exactly how depressed they are. Right? And so how reliable your measure is, according to classic test theory, is this portion of, okay, their true score divided by true score plus error score, with the assumption being that whenever a person is answering, they're probably not going to put exactly their true score. There's going to be some error as part of that measurement, and we'll talk about why that happens, what types of error there are. Excuse excuse me, in a minute. But again, the closer you can come when measuring something to the true, getting more true score and less error. So if there's 0 error, true score over true score, proportion is 1, or 100%. You have 100% reliability. As that error score increases, the more error that's included in your measurement, the more obfuscated, the more clouded the true score is, and the lower that percentage becomes, the poorer your reliability. Okay. So what about that error? Well, a couple different types of error that we typically see. They are bias and random error. Now, bias, as opposed to random error, is systematic error, right? Where some people or some participants, maybe they're not people, are measured differently than others, and not because they're really different. They're really truly different on that measure, but just that your measure is acting differently with them than with other people, right? And so maybe there's some variable that correlates with the error. And most commonly, we worry about the error in measurement being systematically different across levels of an independent variable, right? When that happens, we've got a systematic difference across levels of the IV. That's an error. That's a confound, right? But bias can also exist when measuring the error correlates with some participant characteristic, right? So maybe women who demonstrated the same behaviors as men in some observations, the exact same thing, but they're given higher scores on some measure of aggression. Okay, so if that's happening, you've got some bias, and it's systematic, where one group is being measured differently for having the same thing being exhibited, right? The same level of construct. So people having the same level of depression, one gets a higher or lower score for some other reason. Then random error is non-systematic error. Instead of just some individuals being measured differently than others, it's where there's a recognition that to some extent all individuals aren't going to be measured with 100% accuracy. And these errors aren't correlated with any participant characteristic, and they aren't systematic across levels of an IV. And random error typically won't make us think we had an effect when there wasn't, but it may hide an effect, right? Too much noise, too much static to detect the signal that's there can happen with too much random error, which would lead you to make a type 2 error, right? So where does this error come from? 3 typical candidates, either from the participant, they bring an error themselves, from the experimenter in terms of what you do or the way you're designing, you're collecting the data, and then the measure or instrument itself. We'll talk about these 3 in a minute, but before we do, just want to touch on one other thing here, and that's that fortunately, even when we can't eliminate error, what we can do is estimate how much error is in our measurement. Right? There's statistical procedures developed that help us estimate the degree to which error may be distorting true scores. And most commonly, this involves calculating reliability coefficients based on things like test-retest reliability, inter-rater reliability, and internal consistency. So test-retest reliability is when, so you first develop a measure and you want to show that it's got good reliability. You're not going to use it in a study yet, but you give it to some people and you measure their level of depression, and you give them that same measure a few days later, and people, each person should score somewhat similarly on your measure from time 1 to time 2, right? If you're measuring things reliably and assuming their depression hasn't changed, they should get similar scores. If so, you've got good test-retest reliability. And the more similar scores are across time, the higher that coefficient will be, closer to, usually it goes from 0 to 1. Inter-rater reliability is most often used when you have people either observing behaviors or reading written reports and then making some judgment about level of a construct. Okay, we watch these kids on the playground, and on a scale of 1 to 5, how aggressive were they? Right? And so you look at, when 2 people looked at the same kid doing the same thing, to what extent did they rate that kid the same? And if consistently different raters rate the same thing similarly, you've got high inter-rater reliability. As you get more drift, where, no, I thought it was a 5, I thought it was a 4, oh, I thought it was a 3. When that happens, you have more disagreement, you'll have, obviously, lower inter-rater reliability. And then the last one, internal consistency, applies to a scale or measure where you have multiple questions, right? So maybe you have 5 questions, all of them about depression. Because again, if you're trying to measure depression, you're going to get a better measure of it asking 5 questions than asking 1, right? The more, there's some diminishing returns eventually, but more is usually better when measuring, more data points. So when you have these 5 questions about depression, measures of internal consistency, which are things like an alpha coefficient or item total correlations, excuse me, look at, okay, when people said they were depressed on question 1, when you go down to question 2, did that same person say they were very depressed in 3 and 4 and 5, right? Or, and if so, you've got high internal consistency. But if you have somebody that says, oh yeah, I'm really depressed on question 1, question 2, no, not so much. Okay, well, those 2 questions may not be measuring the same thing then. Your measure, your scale, may not be internally consistent. You might be measuring 2 different things or more. But again, these things can help us get some estimate of how much error is present, and typically we set limits on how much error we're willing to have in a measurement to use it, and how much error is okay depends on which particular coefficient you're talking about and what field you're studying in. So you really have to kind of read the articles in the field you're studying and say, okay, what are people saying they used to justify that their measure has adequate psychometric properties, which reliability and validity of a measure are the psychometric properties. But typically we're looking at coefficients that are 0.9 and above. Sometimes you see things as low as 0.7, but typically they're higher than. You won't see anything lower than 0.7 being reported as, oh yes, this has good reliability. It's at least 0.7 is kind of the lowest you'll see for any type of measure of reliability. Okay. Okay, so for coming back to the sources of error, the first of the 3 we'll talk about would be the participant, him or herself. And so with participants, a couple things you have to worry about, one of which is demand characteristics. So demand characteristics are basically hints that participants pick up on, either in the materials or from the experimenters, about what responses are expected of them. Now, these hints don't need to be read accurately to have an effect on their score, right? So they might be wrong about what they think is expected of them. Doesn't matter. As long as there's something in that question where they think, oh, this is what they want, okay, now they're not giving you their true answer. You're getting less total true score. You're getting more error score there. Okay. So to deal with this, typically what you do is you try to, if you can, measure things unobtrusively. Right? If you're really worried about demand characteristics, then you measure people without them knowing you're measuring them, which there's some ethical concerns about that, right? Because we're supposed to have informed consent to gather data from people. The exception being if no identifying information is gathered, then you don't necessarily need informed consent. If you're not going to do anything to them, all you're doing is observing, and they're in a public place, then you don't need their consent. Right? Like if you wanted to do a study of patterns of commenting on discussion boards, on the internet, you don't have to go track down every troll and get them to sign a form. That data is out there and it's public knowledge. And when you're gathering it, nobody knows you're gathering it, so you could gather that unobtrusively. Right? But again, there's a limited amount of data that can be easily measured unobtrusively, right? Especially for a lot of the things we're most interested in. So another choice you might make is try to disguise your measure somehow, or disguise the hypothesis of your study. So maybe you'll throw in some other questions or other measures frankly, to mislead the participants, to make them think, oh, this study's about this, oh, and I have these other questions about this too, okay, blah, blah, blah. But really, the things they think are fluff are your main questions. The things they think it's about is the fluff. Again, some ethical questions about that. When we lie to participants, that's somewhat unethical. Right? And as researchers, you're obliged to debrief them afterwards, where you tell them, okay, sorry, we lied to you. Here's why we lied to you. Here's really what the study was about.
Please don't tell your friends in case they take the study. Right? Which is like, okay, well, everything's fine, we tell the truth eventually. But there is still this kind of problem where, especially in the 60s, 70s, 80s, in the behavioral sciences, a lot of good research was done with a lot of lying to people and misleading them, and it got to the point where the public developed kind of this distrust of behavioral scientists. And so now people will come to your study kind of looking for, okay, they're trying to trick me, and if they're with another participant, oh, they're probably a confederate, and they're not really a participant, right? So they've gotten more savvy, and unfortunately, even if you're not trying to trick them, they may think you are, which can affect their answers. So we try to use as little deception as possible, unless you really need to. Excuse me. Another thing that participants can bring with them in terms of bias as a source of error would be social desirability bias, right? And this is when participants distort their responses in an effort to look good, right? So when they're denying racist or homophobic attitudes, oh no, I love everybody, because they're afraid that somebody's going to see what they put, and there's kind of this socially desirable response. And studies have shown that social desirability is less when we assure people of anonymity, but it's not nothing. There's still some social desirability present. People can't shake that idea that, well, somebody might see this, right? So what do you do? Well, a couple things. One, you can avoid loaded questions or language where there's clearly a right answer. So if you're wanting to ask somebody about a kind of a sensitive topic, be careful in how you word it and the options you give. That will provide people options where you can get some variability in your measure on both sides of the issue, without them having to endorse kind of attitudes like, oh yeah, I really hate this group, they're the worst ever, because you're probably not going to get that. So think about that when wording questions on a survey or designing some other measure. The other thing you can do, other than trying to eliminate social desirability, is if you're worried that it's going to be present, you can measure. There are several scales out there that are designed to measure social desirability. Right? Well, they ask questions like, "Oh, do you read the newspaper every day?" and all this stuff. Stuff that people think, "Oh yeah, I should do that." And so, if that group of people is going to be prone to a social desirability bias, they'll say, "Yeah, I do that, I do that, I do that." Right? And that's not your main measure. You give some other measure, but if you have a lot of people scoring high on that measure, then you say, "Oh well, my other measure may also be impacted by social desirability." But if nobody on that measure of social desirability is real high, everybody's pretty low, you say, well, no, in this sample, social desirability didn't seem to be a big factor. So on my other measure of anxiety and depression, I don't think social desirability contributed to their responses to any kind of large extent. Third thing participants can bring with them, inconstancy and mistakes. Right, so people are inconstant, right? They're not static. They're very dynamic. And you give me a survey question today, and I might answer, a 3 on it. Question on a scale of 1 to 5. Well, how do you feel? Oh, 3. Tomorrow you come back, and give me that same exact question. Oh no, I'm a 4. Right? Come back next day, I'm a 3 again, then a 4. Probably my answer would vary across situations around some number between 3 and 4. Maybe, maybe my true score is 3.5. The point is there's some randomness associated with measuring dynamic entities like human behavior, attitudes, thoughts, emotions, right? In addition to that kind of just randomness because we're random people, some people might intend to respond, oh, very true to something, but accidentally mark not at all true, right? They just get confused and mismark something. So there's some error in your measurement just from, quite simply, a data entry error on the participant's part. The best way to deal with this, unfortunately, is to try to get a large sample of behavior, right? And this goes to both number of people, right? Because you're going to have some people screwing up. If you get a large enough group, there should be hopefully enough true data in there that it won't be distorted by some errors. Where if you have a very small sample, just a couple of people making errors can throw everything off. And beyond sample people, talk about sample behavior. Going back to, like I said, if you're measuring depression and you ask one question about depression, well, if there's some error associated with that one question, your whole measure of depression is flawed. Whereas if you have 5 questions, well, if one of the questions was kind of wonky and had a bunch of error in it, you can potentially throw that one question out, keep the other 4, and still have a good measure of depression, right? So typically, when you're interested in something, some construct, you're going to ask multiple questions about it or measure it in multiple ways. And this could include multiple reporters. So having the person report on it, having their significant other report on it, having their parent report on it, observing it yourself, getting written self-report, getting a physiological measurement, all these different things. The more behavior you can get up to a point, the more accurate picture you're going to get of the construct you're trying to measure, because you'll be able to sift out the error, because they shouldn't have the same error in every modality. Right? The other sources of error we'll talk about, the experimenters and the measures. So the experimenters, the people who administer and score the measure in this instance, might be prone to expectancy effects, right? Where experimenters may intentionally or even unintentionally skew the results by treating participants differently based on what condition, what level of the independent variable they're in, or scoring their responses differently, right? And this especially happens whenever there's large amounts of subjectivity in whatever you're measuring. So if it's observation, you're observing couples, and you're observing a couple that's in your therapy condition and a couple that's not in the therapy condition. You're watching the couple in the therapy condition, and one of them kind of smiles, but it could be they just had a little gas. Like, oh no, they're smiling, yeah, so yeah, they're very happy. And the couple in the other condition that didn't have the therapy, they kind of smile, and you go, oh yeah, it's probably just gas. They're not happy, right? Because you expect to see one thing or the other that might tend to introduce some bias in terms of interpreting behaviors. And just real quick, a little aside, interesting story. This has been documented empirically, really interesting way, where some researchers got a bunch of genetically identical mice, sibling mice, and sent them to different labs to tell you, we need you to take these mice and teach them to run a maze. We're looking at this theory of learning, yada yada. So not really what they're interested in. They said, oh yeah, these are some really smart mice. They sent to this one lab. To other labs, they said, these mice, they're kind of dumb, so do what you can with them. What happens? Well, the smart mice learn the maze very quickly. The dumb mice take much longer to learn the maze. They're genetically identical mice. They weren't smart, they weren't dumb. They just said, oh, these are smart, these are dumb, randomly. But there was an expectancy effect that impacted how they interacted with those mice and how they measured their behavior. Excuse me. And just like participants, experimenters can make mistakes, right? When giving a measure or when scoring it. Just simple computation or data entry errors contribute to error in measurement. So in terms of dealing with error from the experimenter side, one approach would be standardization of measurement. And that's where you're trying to create a standardized set of procedures for measurement and scoring, where everybody experiences the same thing in the same order. Right? And standardized scoring is especially important if you're collecting observational data, right? Because we want to try to limit the impact of the subjectivity and bias. And if you have maybe multiple raters rating stuff, you're going to do lots of training on your standardization, so everybody knows this is exactly what a 4 looks like on the scale. This is what a 5 looks like. This is what a 3 looks like. Here's the difference between a 3 and a 4 and a 5, right? Here's an example of kind of a borderline behavior. Which one is a 4? Which one is a 5? And you go through all this stuff so everybody knows exactly how to use the instrument that you're using. And the more you do that, the more reliable your measure will be. Another approach to kind of deal with especially those expectancy effects will be blinding or masking, right? This is where you have the people who interact with the participants and or who score their responses not know what condition the participants are in. Right? This way, they can't expect them to do well or do poorly because they don't know if they're in the control group or if they're in the experimental group. And they might not even know what the study is about. So you may just recruit some grad students to code this data, and they don't even know anything about your hypothesis at all. Then there's really difficult for there to be expectancy effects coming in. And if the experimenters don't know what condition they're in, and the participants don't know, so if nobody knows what condition they're in, neither the experimenters nor the participants, you're talking about a double blind. Right? If just one group doesn't know, it's a single blind. So participants can be a source of error, experimenters can be a source of error, and the measure itself can be a source of error. You might have vague instructions, right? So some participant errors really may be not due to the participants misunderstanding things, but due to poorly worded instructions regarding how to complete the measure. So you want to be sure that you're very explicit and complete when directing people how to enter the data that you're looking for, so that you're going to get the data you're looking for. The kind of classic example, if you put you want to know about participants' biological sex in the demographics section, you put sex, colon, and a space. Some participants will put yes please or yesterday, and some of them are just being jerks. Some may have misunderstood, but if you want to limit that, be very explicit. So biological sex, colon, male, female, transgender, other, right? Intersex, whatever options you want to put. So, but make it very clear. Similar to that, you may have problems with just poor design. It may not be clear how to indicate your answers, and this usually has to do with just formatting issues. If people don't know, am I supposed to circle which letter corresponds to what I'm doing, write it in, or should I put a dot between the two answers that I think I'm most like? So again, if you ever have to design your own survey, assume that people are cattle and need to be directed and will be hopelessly lost if you don't tell them exactly where to go, when to go there, and what to do when they get there. But again, designing measures is tough, so as much as you can, I would recommend finding existing measures that have known psychometric properties, that are known to be reliable and valid. Okay, so kind of the first part of talking about measurement, we'll talk about reliability. Now the second part of measuring variables, we'll talk about validity. And when we talk about validity in terms of measurement or in terms of variables, we're talking about construct validity. Right? Because again, we're interested in these constructs, these schemas, and we want to know, okay, to what degree are the data that we've measured an accurate estimate of the construct we're trying to estimate. Okay. Excuse me. So, what's the relationship between validity and reliability? You can't have validity without reliability. You could have a measure that's reliable but not valid, but you can't have a measure that's valid if it's not reliable. So you could have a scale that you get on that scale, and every day it tells you that you weigh 100 pounds. And let's say, for sake of argument, that you don't weigh 100 pounds, you weigh 180 pounds. Well, then that scale wasn't a very valid measure of your weight. But if every day it told you 100, well, that's very reliable, and never gave you a different answer, right? Another way to think about it would be shooting arrows at a target, right? Robin Hood. If you're consistently grouping arrows in the same place, that's reliability. But they could be consistently grouped out in the outer ring. So you're always shooting high and to the left, high and to the left, high and to the left. Very reliable shooter. But it's not valid. You didn't hit the bullseye, because the bullseye represents the heart of what the construct is. And so, if you hit the bullseye once, it's like, oh, do you have validity? Maybe. But if you're shooting 5 times, you hit the bullseye once, and then the outer ring the other 4 times, no, it's not validity. You may have gotten lucky once, so we don't know overall if you're really a good shooter or not. But if you cluster you got 5 arrows all in the bullseye, well, yeah, now we've got a kind of this valid measure of your shooting ability. You're a good shooter, right? Because you have the reliability and the validity. So to have validity, you must have reliability. But for reliability, you don't necessarily need validity. So some measurement and validity issues related to more directly to internal validity, in terms of they have a kind of a clear impact on our ability to draw conclusions about cause-effect relationships. And we'll talk in a minute about other aspects which are more relevant about the degree to which our findings can be generalized outside the study setting, external validity. But for now, focusing on kind of things related to internal validity, look at the content validity of a measure, which all of these are, anytime you're talking about any validity related to a measure, they're all subsets of construct validity. So part of construct validity is content validity. It's subsumed under the larger idea of construct validity. So content validity is the extent to which items are relevant and representative of the construct for a particular assessment purpose. So the extent to which items are relevant and representative of the construct. So two pieces of that. One, did you ask enough questions or make enough observations? Right. So if you're thinking about, the construct is depression, and you ask several questions about depressed mood. Do you feel blue? Do you feel sad? Do you feel low? Okay, those all may be good. You may get a good reliable thing, but your measure may not have good content validity, because the concept, the construct of depression, as we understand it according to the DSM-4 psychopathological conceptualization, is you have affective symptoms, mood symptoms, you've got these vegetative physical symptoms, and you've got cognitive symptoms, right? So you need to ask about mood, you need to ask about either weight gain or sleep loss, something in there, appetite, you need to ask about impaired concentration, feelings of thoughts of guilt, things like that. If you ask about all of that, then yeah, you might have good content validity. So are you asking broadly enough things that they're going to be representative of this large construct? Excuse me. The other thing is you need to make sure that you know exactly what it is you want to measure, because sometimes you think, oh, I'm interested in depression, so I'm going to use this measure, make sure it has good content validity. And maybe you're not interested in depression as a large construct. Maybe you're interested in the cognitive aspect of depression, or the mood component of depression. That's fine. Just specify that in your paper that this is what I'm studying: depressed mood. So I'm measuring depressed mood. I'm not measuring depression. I'm measuring depressed mood. You're good to go. Okay, so we ask enough questions to cover the content, and they're all relevant to that construct. They're not off-the-wall things. Internal consistency. Excuse me. This is often talked about regarding reliability, but really is more of an indicator of validity. Right? So when you have multiple questions or observations that are supposed to tap the same construct, then they should be internally consistent. Right? If you're measuring anger and a participant is really angry, then she should look angry on all the questions. If there's one or two she doesn't look angry on, then you don't have much internal consistency. And again, as I said before, you use things like Cronbach's alpha, inter-atom correlations to help determine this, usually after the fact. So you've given the measure, and then you look at these data. But often, when you're choosing a measure, you'll look and see, okay, somebody else used it, and they reported the level of internal consistency was this, right? So sometimes you'll choose your measure based on the published psychometric properties of that measure, how reliable and valid it was in the past. But you'll always report on, in your own study, how reliable it appeared to be with your particular sample as well. Okay, so content validity, internal consistency, and then convergent and discriminant validity. So these two things are looking at how your measure relates to other measures of other constructs. Right? So convergent validity says that your measure should, the results, the data should converge with other measures of the same construct. So I have a measure of depression. the people that score high on my measure, do they also score high on the Beck depression of inventory or somebody else's measure of depression? If so, that's convergent validity. So these two measures of the same construct, the people's scores are correlated when they take both tests. That's convergent validity. If they don't, that's poor convergent validity. And then discriminant validity is that scores on the measure of a construct don't relate perfectly to measures of other constructs. Right? So scores on my measure of depression, and then I have somebody else's measure of anxiety. Okay, those scores might be somewhat correlated because those constructs are somewhat correlated, but if they're perfectly correlated, then maybe I'm not measuring depression. Maybe really I'm measuring anxiety. So I want to show that my measure of this construct is not perfectly correlated with measures of other constructs. That there's a discrimination between, oh yeah, I'm measuring this, not that, because they're not that similar. Okay, that would be discriminant validity. Now, coming back to the other side of the coin here, measurement validity related to external and ecological validity. And again, external validity is about being able to generalize the conclusions you draw at the end. And ecological validity is related to the degree to which your procedures and measures reflect the real world. Right? So, a pen and paper measure of marital satisfaction versus behavioral observation of a couple at home. Right? Observing couples at home is going to have higher ecological validity because the data you're gathering is more like what you're trying to, the construct. If your construct is, marital interactions, that's more real world than having them answer questions on pencil and paper. Right? But things that have high ecological validity don't necessarily have high external validity, right? Because it may look like one aspect of the real world, but not all aspects are all context, right? It may not generalize beyond, some particular couple's homes. Okay. Anyway, in terms of things we'll look at, criterion validity, which we look at predictive validity and concurrent validity are the two types of criterion validity. Criterion validity has implications for the relevance of the data generated by a measure. So it looks at how scores in the measure relate to observable outcomes. So similar to convergent, like convergent is, okay, you scored this on this measure of the construct, similar to that measure of the construct. Here, a measure of a construct has to relate to some measure, some outcome. So if I have a measure of depression, instead of getting another measure of depression, I find some outcome that's logically related to depression, maybe a number of days missed at work. Okay? And if my measure of depression is related to number of days missed at work, then that's criterion validity, right? My measure is related to this behavioral kind of outcome predictive thing. Excuse me. And if you look at it, and the difference between predictive and concurrent is quite simply, if I measure this construct now, and I'm trying to see if it relates to some behavior in the future, that's predictive validity. And then if I say, okay, I measure this now, this construct now, and I measure this outcome at the same time, then it's concurrent criterion validity, right? It's just a matter of time frame. Last thing under this part would be discriminative validity. So different than discriminant. Sounds very similar. Discriminative validity is related to criterion validity, right? This is where can the measure be used to reliably discriminate between groups who should differ on the construct being measured. So again, going back to depression, does my measure of depression, the people that have been diagnosed with major depressive disorder, so some psychologists or psychiatrists put the stamp, yep, they have this diagnosis, do they score higher on my measure of depression than non-clinically depressed individuals? If so, then yeah, my measure discriminates between this group and that group, and I've got discriminative validity. Okay, time for a quick concept check, make sure things are making sense. If you're going to use some measure of anxiety, and you find that it's correlated with an established measure of anxiety, but it's not correlated with an established measure of aggression, what type of or types of validity have you established or maybe failed to establish? talking about convergent, divergent, discriminant, criterion, predictor, right? Convergent validity, because it's converging with another measure of anxiety, and divergent validity, because it's not correlating too highly with a measure of a different construct. Right? So both good convergent and good divergent. If it was correlated with both types of measures, it would maybe have good convergent but poor divergent. Right? If your measure of anxiety correlated high with measure of aggression, that's poor divergent validity. Okay.
Okay, so now we'll talk about sensitivity, specificity of a measure, and also the variability of data that you're looking at and how that relates to sensitivity. Okay, first off, when talking about sensitivity, when talking about the measurement of variables, there's really two different and distinct meanings here, two different distinct definitions. The first one I'll mention is sensitivity is the degree to which your measure is able to detect differences among participants on the construct you're interested in. So the degree to which your measure is able to detect differences among participants on the construct you're interested in. So if you have two people and you're looking at aggressiveness, how aggressive someone is being, and one's being slightly more aggressive than the other, the way you're measuring aggressiveness, will you show that? Or does it take large differences for it to show up as a difference on your measure? How sensitive is your measure to detecting these subtle differences? The second definition really applies more whenever you're talking about diagnosis or labeling, putting someone into a particular category. This is sometimes you hear talk about sensitivity and specificity of a measure. And this has to do with can your measure accurately identify someone as belonging to a particular category, right? So if I have a measure of PTSD, right, and I say, okay, if you score 10 or higher, then I'm going to say you have PTSD. Now, if I have some independent measure of PTSD that I can confirm, yeah, they have it, no, they don't, they've been diagnosed by some professional, I give those people my measure. If everybody that I give my measure to that has PTSD, my measure says, yep, they have it, I have good sensitivity. If I miss some, there are some people that have it, my measure said, nope, they didn't have it, and I have poor sensitivity. And you can actually calculate the percentage of sensitivity. But the thing about that is, the sensitivity of a measure depends on some decision you make, right? Some cut score, typically, where, okay, the scores on the scale that I made up are 0 to 20, and I'm going to say if you score 10 or higher, I'm going to say you have this disorder, you belong to this category. And I can move that cut score. I say, well, I'm not going to go say 10, I'm going to say 20, or I'm going to say 5. And moving that cut score will change the sensitivity of the measure in terms of that definition. Okay, so in that first definition, the sensitivity doesn't matter on your cut score. It matters on how good the measure is at showing up small differences. The second definition of sensitivity, again, depends on some decision point that you make. And that's where often you see sensitivity paired with specificity. Right? So where, in terms of deciding if someone belongs to a category, if they get this diagnosis or not, sensitivity is, okay, am I going to be able to find everybody who has it? Am I going to be sensitive to those positive cases? Specificity, in terms of that, answers the question, do you accurately say someone doesn't belong in a particular category? Right? So if I have a scale of PTSD scores and it ranges from 0 to 20, and I say if you score above a 0 you have PTSD, I'll have perfect sensitivity. There won't be anybody that has it that I say doesn't have it, right? Because everybody will get higher than a 0. But I'll have really poor specificity because I'll say everybody has it, and not everybody does. So there's that balance between sensitivity and specificity where you're setting that cut score, that decision point in terms of diagnosing or categorizing or labeling people. And that's where your sensitivity and specificity talked about together. For most of you, you'll probably focus more on the first definition of sensitivity in terms of, can I pick up on small differences, small gradations on the construct I'm looking at? Unless in fact you are looking at something where you're talking about diagnosis. Generally, we'll talk more about, in the rest of this lecture, we'll talk more about that first definition of specificity. Okay, so in terms of that first definition of specificity, being able to see those small differences, what's its relationship to reliability and validity? You can't have a sensitive measure unless that measure is reliable and valid. Right? It has to be measuring what you say you're measuring, and it has to do it reliably. If it's sometimes right and sometimes wrong, then you're not going to be able to pick up on small differences because you're sometimes going to be wrong. Right? So reliability and validity are prerequisites for sensitivity. Okay? Or you could say that reliability and validity will limit the sensitivity of your measure. But it's important to keep in mind that they aren't the only considerations. You also need to be mindful of how the measure is designed and how the data will be collected. And a lot of that has to do with the relation to how variable the scores might be, the data might be that you're looking at, right? So you need to think about, okay, I'm measuring aggression, I'm measuring wealth, whatever it is, in the population you're looking at. How different are people going to be? Are there going to be small differences? Are there going to be big differences? Will there be any differences? Right? And you need some differences for whatever type of study you're doing. You have to have variability on a measure to do anything with it. Right? So when thinking about that, you also want to be thinking as much as you can about possible analyses you could do with your data when figuring out which measure to use. So you want to think about, when I'm going to measure this thing, do I want to measure it as a dichotomous variable, or in some other type of categorical variable, or as a continuous variable? Right, where dichotomous is it's A or B, yes or no. And categorical is same thing, but just more than two choices. Is it red, yellow, or blue? Continuous is, okay, well, how red is it? What degree of redness does this thing have? Okay, so some variables are naturally going to be dichotomous or categorical, but and others will naturally be continuous. Let's say most variables potentially can be continuous variables. You go, well, I know there's some gender. Gender is clearly categorical. Maybe. Like if you're talking about gender in terms of the psychological, sociological construct, definitely continuous. How masculine you are and how feminine you are, probably on two separate continuums. Right? Definitely continuous, not naturally dichotomous. Even biological sex, arguably not clearly dichotomous, and maybe it makes more sense to measure that type of thing on a continuum. But you want to think about the data you're looking at. Is it naturally going to be dichotomous, categorical, or continuous? And then you want to think about, well, what makes the most sense to me in terms of finding what I want to find. Right? And this relates to sensitivity, because dichotomous and categorical approaches to measurement are naturally going to be less sensitive approaches. Right? So if I'm measuring gender, and let's say I'm doing it with a dichotomous scale, do you consider yourself a masculine person or a feminine person? Okay, well, everybody who's at all tips one way or the other, like all people say, yeah, I guess I'm more masculine, they're all going to be in one category. And so you're going to have some people in that category that are just, I could have almost said feminine, but no, more masculine. You're also going to people in that same category that are like, oh yeah, I'm so masculine, I'm so machismo. Right? And those two people are going to have the same score on your measure. They're both equally masculine, because you aren't measuring any difference. So you're losing a lot of sensitivity by choosing to measure something dichotomously. And categorical with more categories is obviously more sensitive than dichotomous, but the most sensitivity will be if you're measuring something in a continuous scale, where they could have any level of masculinity or femininity, or whatever construct you're measuring. The more levels, typically, the better in terms of sensitivity. And you can think about this too in terms of if you're doing kind of surveys. We say, well, I'm going to ask these questions, and they're going to rate the degree to which they agree or disagree to something on a scale of 1 to 5, 1 to 7, 1 to 30, whatever it is. Again, the more choices you give, the more sensitivity. But at some point, especially when constructing a survey, you may have not meaningful differences. Like if you had to answer a survey where you had to say the degree to which you agreed or disagreed with something, and the anchors were at 1 and 30, okay, what's the difference between saying, yeah, 27, no, 26, Is there a meaningful difference there? Probably not for most people. So you want to think about sensitivity, well, you also want to think about meaningful differences. Okay, but generally, go for more continuous ways of measuring than dichotomous or categorical. Another thing to think about are floor and ceiling effects. So think about how people in your sample might respond to whatever measure you're using. And a floor effect is whenever people are scoring so low on your measure that they would do worse than you're seeing, but you can't see it because there's this floor. So if you're giving somebody a test of mathematical ability, and you're using a college calculus exam, but you're giving it to kindergartners, and you want to say, okay, will this tutoring improve kindergartners' math skills? Well, guess what? Everybody's going to score a 0, and you won't be able to score any lower, and so you won't see any effect. Even if you did improve their math skills, you won't see it because they're all scoring so low. The measure's too hard for them. Ceiling effect, the opposite way, where they could score higher, but your measure doesn't go up enough. Right? So you give those college calculus students a kindergarten math test. I want to see the difference between, I'm going to give some college students tutoring and some not, and then you give both groups a kindergarten math test. Well, they're both going to do 100 on it. They can't score any higher. Well, my tutoring didn't work. Maybe it did, maybe it didn't. You couldn't see it working because there was a ceiling on your measure. There was a ceiling effect. Right? So think about possible ceiling and floor effects with your approach to measurement. And then also think about whether the behavior, the construct you're measuring is liable to change. Right? And if you're looking at any kind of pre-post or any kind of cause-effect thing, this is really important. Because some behaviors and characteristics are more volatile, more mutable than others. You might be able to get people to move on some measures of attitudes about spirituality. Right? You're going to show them something or do something to them. You might see some movement on your measurement of attitude towards spirituality. But you're probably not going to see changes in their core beliefs unless you do something that you wouldn't get I or B approval for. So think about, okay, what I'm measuring, is it possible to see change on how I'm measuring this thing? Right? So that's one more thing to keep in mind. Okay, the fourth and final thing we'll talk about that influences conclusions you can draw about your data, depending on how you're choosing to measure things, is one of the more basic ones, the scale of measure. So you have nominal measurement, which is you use to describe categorical variables. So ask people, what's your favorite color? Red, blue, yellow, orange, green. Okay, this person's red, this person's blue. Okay, well, there were this many reds and this many blues. But you can't say this person is way more red than this person is and they're way more blue. No, they're red and they're blue. You can't compare data points. So I'd say it's pretty rare to have a dependent variable that would be measured in a nominal scale unless you're doing qualitative research, which you're not going to be doing. But your independent variable very typically would be on a nominal scale. But the things you're measuring for dependent variables, if you're looking at correlational data, probably not, at least not more than one of your variables would be on the nominal scale of measurement. Ordinal scale gives you a bit more information, right? So where nominal, all you know is, okay, this is different than this. Ordinal is for outcomes or observations that can be ordered along some continuum. So now you know, okay, you were first place, you were second place. Okay, yeah, first is different than second. Red is different than blue. But now I know first was faster than second. Right? I don't know that red was faster than blue or redder than blue. It was red and blue. They were just different. So ordinal gives you a bit more information. It gives you, okay, yeah, they're different, and there's an order. This one came before this one came after this other one. Right? So asking people to rank order their choices. You can get ordinal data, and you can do a bit more with that. But you're still limited with your statistical analyses at this level of measurement. And it's another thing to keep in mind, the further you go up this on the scale of measure from nominal up to ratio, the closer you get to ratio, the more you can do mathematically with the data in terms of finding patterns. Interval, so adds to ordinal, so beyond difference in order, now you have the amount of difference, right? The requirement here for an interval scale of measure is that the variable that you're measuring, the way you're measuring it, you have equal intervals. So you know how much more or less of a quality one outcome has than another, right? So first place, second place, third place with ordinal. First place could have come in after an hour. Second place came in right behind them. They were racing neck and neck, and they were just a few seconds behind. And then third place was another hour later. Well, if all you know is ordinal, 1, 2, 3, you don't know that the third place was so far from the other two. With interval data, you will know that because you know how many pieces of whatever you're looking at each one is distant from the other. But one thing we can't do with interval data that we often try to do is talk about the ratio between different people's scores. You can't talk about somebody having twice as much as someone else when it's measured on a ratio scale because you didn't have a true zero on your scale of measure. So most of the things you'll see with paper and pencil measures of psychological constructs, where you have that, extent to which you'd agree, 1 to 7, 1 to 5, whatever it is. Typically you have, strongly disagree on one side, strongly agree on the other, or no, I didn't like it, to yes, I did like it. There's not a true zero anywhere in there, right? You're either disliking something or you're liking it. There's no absence of liking. If there's not an absence of the thing you're measuring, then you can't talk about it in ratios, which means if you have two groups given the Beck Depression Inventory, which is this multi-item scale that has a bunch of things that ask symptoms of depression, and you score 0, 1, or 2, I think on all those, and you add it up, you can get the average for each group. Okay, this group averaged 4.2, this group averaged 8.4. You can't say this group scored twice as high as this other group. There is no twice as, because you can't have a ratio, you can't use ratio logic if there's no true zero. You can just say they scored higher. Okay. So the only time you can make those ratio statements is if you're using ratio data, right, where you have order and degree of difference, not just amount of difference. And this requires a true zero, which means that when you're measuring something, it's possible for someone to have absolutely none of the construct you're measuring. And this is, we often treat a lot of interval data as if it were ratio, and we just pretend that it's fine. But it's rare to have things that are truly ratio with things we're interested in. Like, so things that are ratio, you think, well, temperature, if you're measuring in Celsius or Fahrenheit, no, it can't be ratio. Only if you're measuring in Kelvin, where 0 Kelvin is no heat. Right? So I'd say just in general, shy away from making comparisons of any data that are ratio in nature, meaning twice as much, 3 times as much, half as much, just talking about difference, because most things that are being measured are going to be measured on interval scales. Okay, now just a quick overview of the different approaches to measurement, and there are lots and lots of different ways to measure the constructs that you're interested in. But I'd say typically you can break it down to one of 3 categories when we're talking about measuring behavior. Right? When we're asking people about someone's behavior, when we're measuring physiological phenomenon, or we're directly observing behavior. So when we're asking people about someone's behavior, we'll sometimes ask the person themselves about their own behavior, or we'll ask others. We'll ask maybe a parent or a child or a spouse or co-workers, right, to report on someone else. So we'll talk about self-report and other report approaches to measurement. And different ways to do this. One kind of common breakdown is looking at interviews versus surveys and questionnaires. For interviews, they can differ in terms of being the level of structure. So you could have, okay, I have these 10 questions, I'm asking everybody these questions, no matter what they say, they're getting these questions in this order. Okay, that's a structured interview, and doing that leads to good standardization, so you treat everybody the same. But you may miss some important information. So you may say, well, I'll use a semi-structured interview. I've got these 10 questions, but on like question number 2, if they say yes, I'll follow up with this question. If they say no, I won't follow up. Right? So you have this kind of branching decision tree, and that gets you a little better information. But people will then be getting slightly different experiences, which is less standardized, introducing more error. And you have totally unstructured interviews, which is what you, I say, pretty commonly use in the clinical counseling field. So when you're not doing research, you're just working with people, you do unstructured interviews. And you may have some ideas about things you want to talk about, but really, the next question you ask depends on the last thing they said. In interview can be a great way to get rich data, especially if you're doing a qualitative study. But again, think about what the data are going to be when you get them. If you're doing an interview, you're getting a bunch of words back. If you have to do a quantitative study, you have to figure out a way to transmit those words into numbers that indicate meaningful differences between people. So for your own proposal, I'd say stick to surveys and questionnaires if you're doing self or other report. And those can vary in quality as well. It's best if they're standardized rules for administering surveys or questionnaires, and standardized rules for scoring, and often for like the really well-known questionnaires or surveys, there are normative comparison groups. So if you give somebody the PAI, the Personality Assessment Inventory, they get some score on depression. Okay, they're at 70T. Okay, they're 2 standard deviations above the mean. That means that compared to a big group of people that this test was given to earlier, they're reporting significantly more depressive symptoms than 95% of those people. And if you have lots of different normative groups like the PI does, you can say, okay, that's compared to the general population. What about compared to people coming into a clinic? So we'll come into a clinic, they're actually at 60T. Okay, so they're pretty depressed in terms of compared to most people, but they're not the most depressed person that would be coming in to see you in a clinic. And so having a normative comparison group gives you even more information. And so there are some really good questionnaires that have those type of data available to you. What about the accuracy and the validity of data by asking people about behaviors? Well, it depends, right? Some things people are unable to know the answer, either about themselves or about someone else. Sometimes they can't remember the answer. Sometimes they don't know the answer yet. It's something that's maybe knowable, but they haven't learned that yet. And then sometimes they know, but they don't want to tell you, and so they're going to lie to you. And again, your more sophisticated questionnaires like PAI, MMPI-2, they have questions built into the test to try to detect when people are lying, if they're trying to mislead you by being overly positive or mislead you by being overly negative. They have some statistical methods to try to tease that out, but it's not perfect. And a lot of the surveys you see in psychological research don't bother with that, and we just trust people to be honest. So, for what it's worth. Physiological measures. So things like heart rate, galvanic skin response, testosterone levels, MRIs, EKGs, all those things. Nice hard data, right? So those are nice in terms of hard to fake, right? Not impossible to fake on physiological measures, especially people that have learned to train their body to respond to internal cues. They can fake things on an EKG, on an MRI, but it takes a very sophisticated faker to do that. Most people can't. So that's good. So you deal with some of the potential accuracy problems of self and other report, right? Maybe. A lot of physiological measures, unfortunately, generate data that can be somewhat ambiguous, left open to interpretation. Right? So if you're measuring galvanic skin response, you're looking at sweating. Okay, this person's sweating, that means they're lying. I'm measuring dishonesty. Maybe they were lying. Maybe they were hot. Maybe they were anxious, and that's why they were sweating, because you're asking them all these questions and it makes them nervous, and they don't. Maybe they're generally an anxious person. Right? So very rare do you find a physiological measure that tells you has a kind of a one-to-one correspondence to a psychological phenomenon. Okay, even with things as sophisticated as MRIs, this part of the brain's lighting up. clearly this is what's happening. Well, not really. There's lots of parts of the brain involved with complex psychological phenomenon, in saying that one dot on a screen can tell you, oh yeah, they're thinking about their mother. It's not that accurate, right? So there's some ambiguity there. Well, what about direct observation? Well, that can be good, right? It's better if it's systematic, right? So if you just go out and you say, okay, well, I'll just go out and I'll watch people. I'll put people in two different settings to see what happens to them. If I turn the heat up in one room and turn it down in another room, and I see what happens. If you just go see what happens, well, you're leaving yourself open to a lot of potential influence of bias, right? You're going to see what you maybe want to see. Whereas if you're more systematic, and before you do the observation, you say, okay, I'm going to look for these things, and I'm going to check if they're there. I'm going to check if they're happening or not happening every 30 seconds. Okay, now you've got a more systematic approach to observation. You're probably going to get more reliable, usable data. But the other thing to keep in mind is that sometimes think, okay, well, we use direct observation, so we're not relying on self-report, we're not relying on these ambiguous measures. Straight to the source, we saw the behavior. Yes, you saw some behavior at some point in time in some setting. If you assume people are consistent all the time and always act the same way, well, you haven't taken very many psychology courses. Right? There's a general consistency to behavior. People aren't perfectly consistent. So you have to remember, if you're going to be doing direct observation, you're getting a sample of a population of behaviors. Right? So if you're observing a couple interacting together, okay, that's a sample of how they interact together all the time. To what degree is it a representative sample of all their interacting behaviors? I don't know. Probably depends on a lot of things, including how big your sample of behaviors was. Okay. A couple things to think about in particular for your study, your proposal. Before you go looking for a measure, clarify your construct. Think about, what is it I'm looking to measure? What am I most interested in? If I'm looking at couples and I'm looking at this maybe intervention that I think is going to impact couples. Okay, well, am I wanting to measure relationship satisfaction? Maybe. Am I wanting to measure perceived intimacy? Okay, that's related to satisfaction, but it's a distinct construct. Maybe I'm wanting to look at relationship conflict, right? Conflict is related to satisfaction, but it's different. What is it you think, especially if you're doing cause and effect, what do you think you're going to affect? And try to get as clear an idea in your head as possible before going off to look for or think about how you're going to measure that thing. Make sure you know what it is you want to measure. And again, the proposal needs to be for a quantitative study, so you need quantifiable data. So whatever approach you're going to use to measuring needs to be able to generate numbers. And I'd say, try to think down the road, okay, if I got these data, here's my question, what statistical test would I use? Because sometimes thinking about that will key you into, oh, yeah, this is a bad way to measure data. There's no way for me to analyze the data if I measured it this way. So try to think down the road a little bit. When looking for things, I'd say best to look for existing measures. There's lots of measures for lots of constructs out there, rather than trying to create your own survey or questionnaire or interview format. If possible, find something that already exists. A good place to do that would be the Mental Measurements Yearbook with tests in print, which is a database on our library's website. In your library databases, just the same place you go and find psych info, Mental Measurements Yearbook is there as well. And then one of the best ways is, whenever you're doing your literature review, you're reading all these articles about the stuff you're interested in. So if you're looking at marital satisfaction and you've got these 10, 20 articles on marital satisfaction, hopefully, look at how they measured it. So look in their method section, and if out of those 20 articles, 15 of them use this one measure, well, that's probably what you should use. That's the standard in the field. And then by using that, it's more easy to compare what you would find to what they found. Right? You can kind of put it in that context. Okay, so that's all for now on measuring variables. But another thing to keep in mind is a lot of the stuff we talked about here will also apply to manipulating variables. More on that next time.